So, we did this global.
Yep.
As I said, we have the window as one system, we have the cladding as one system. So I separate this now, start with the window.
Now we zoom in.
And now we zoom in and we may do the most complicated detail as a setting. And I'd like to start with an aluminium system. So show me the...
We have a nice sample here.
Nice sample here. So what we see, it's tilting window. It's the IGU, triple layered IGU in this case. We see the outer layer of aluminium, we see the inner layer of aluminium, thick sink of the IGU. We see the thermal brakes here. Some insulation material which is brought inside to secure the thermal performance. The outer aluminium, the inner outer aluminium, thermal brake insulation here as well. And if you open and close it, you see this is 1, 2, 3 layers where the whole thing is sealed by. Then again, inner aluminium, outer aluminium, thermal brake, another thermal brake, and lots of foam in the cavities. Why is that?
That's interesting. With the increasement of the insulating value of the glass, they also had to make sure that in this line they also increase the insulation. So they add this foam strip here, they have polyurethane within this element, they have more cavities within these plastic elements, and the same over here. So back then, 20 years ago or so, this was all empty.
And now it's closed to reduce the convection.
Precisely.
Okay, let's now draw this. And in what scale are we going to do this?
I would say 1 to 2 should fit.
Should fit, 1 to 2.
So
dimension, this is 10
centimeters.
Oh, I give it 5 in here. Put something like this. I give it 10 centimeter, makes it like this. I add here. I'm going to do an IGU somewhere here. I do a standard IGU.
Yeah. To do a regular.
Needs to be sealed here, needs to be sealed here. We have an aluminium piece here, an aluminium profile. This is the isolator. There's the other isolator which comes here at the bottom, which we have in here. Then this one needs to be somehow solid. We put some...
So this is the foam precisely.
Zack. We have some more foam in here. As a setting, we do add water tightness at one point, another point, and another point. Then there's an... I'm going to extend it to make it...
To make this higher? Okay.
Higher. I'm going to do that higher. This is going to be, let's say, like this. Zack. The isolator which goes in this way. So this is an isolator. This is isolator 1, 2, 3 positions to seal it. Now we set the insulation as somewhere here, and this works. 10 centimeter.
And then there's the wall again on the inside.
The wall again on the inside. That was 25. Nah, we make it 20. Otherwise, it's too wide in here. Zack. Give it a windowsill.
Yeah, I would do this out of wood.
You want a wood windowsill, you get a wood windowsill. Easy, huh? You just buy.
Yeah. Back then I did this often in marble as a bricklayer.
Nah, I'm not going to do that. We need to somehow have some more insulation material here as well.
This is sometimes also a sort of a block out of plastic insulator, standard product off the shelf, but yeah, it depends also on the contractor.
Now, windowsill.
You make sure it's underneath, precisely.
Yes, it's underneath, and we have to make this.
That's the water
Layer, and to also have a
vapor barrier.
Vapor barrier is fixed here by glue. This is, say, the general layout. We have this one. We come down here with a metal cladding. The metal cladding needs some kind of substructure, which we saw already. Substructure needs to be fixed through the system. You may also clamp the system here. The metal gets down to this, and I actually, at the side, tilt the windowsill. It needs to be sealed here as well. So this is now the aluminium setting.
And then we do wood and plastic.
Wood and plastic, wood and PVC.
P40. Oh, sorry, P40.
Let's do we do the same.
Yeah, insulation, the cladding right now.
Actually does the same. I do exactly this.
Cladding is right now symbolic. We will talk about the cladding later in more detail, just to make sure. Insulation, and then the wall again.
Wall comes here. Are you insisting on your?
Actually, it is also in a fatter line, but we don't talk about line weights right now.
Do you want this still be wood?
Yeah, nice.
The windowsill, and I assume I'm going to have the wood window somewhere there as well. So this stays aside, and we continue with the wood. I will need some kind of wood piece. I would like to drain the water down. I'd like to have it sealed 3 times.
It's sort of kind of like a terrace.
Yes, and I'm gonna draw it this. So this is one piece of wood. Which means we have the window opening to the inside. I have to do the same here. Needs to find its position in this terrace setting as well. I'd like to drain. There comes the IGU. Again, I do a double IGU, simple one. Needs to be sealed as well. This is going to be one piece. And then it's going to be fixed here as well.
Again, strip.
Again, all in wood. Bit simpler than the aluminium setting, but say in principle the same setting. So this needs to be.
Yeah, wooden windows be in the oldest.
We need to do the vapor barrier.
Yep. So we attach that to the wall, and this is the rain skirt to the outside to protect the insulation.
Cladding comes here, inner wall comes here, and that whole thing is detail number 3, and we call it metal cladding wood window, and it's a 1 to 2.
Now PVC.
I'm going to do something similar. I start again with the metal cladding.
Yeah, that's the base.
Fix it as we already know it. We fix it in the wall. It's the same base.
Often the PVC windows are shaped from the contour like the wooden ones, but are made as an extrusion as a little bit like the aluminium, but they are then from the wall thickness a little bit thicker. So in general, if you have a good eye, the experience, you can see the differences directly in the cut.
And windowsill. And this time I'm going to add
the rain and vapor barrier already.
Before I forget. And we have the windowsill, we position here as well. And now the PVC profile. Let's assume we have it, it's an extruded profile, which means it's extruded geometries. It needs to be watertight somewhere here, somewhere here. We need to drain, we come to that later, as piece. And as they are extruded, you may find this kind of weird shapes, which then are with hollow cavities. Can you say something about the cavities while I draw?
Yep. In this case, they often use more cavities in order to isolate. But they often have, because of the weakness of the material itself, they put a big steel square in it or a U profile. So they're inserted after cut in order to reinforce the elements that don't bend over or that they don't bend.
This is what I'm drawing right now.
Precisely, it's a piece of steel.
It's a piece of steel. And then we continue here with an extruded profile. This is covering this area. I may continue here with this kind of geometry. Go down here. And with something like this, it needs to be possible to fix. So
yeah, that's the glass strip that clicks in there.
Glass strip clicks in there. add another cavity in here. The glass needs to be sealed here and here. The IGU ends like this.
So it's the same that the windows are usually glazed from the inside.
Yeah. This is fixed in here. It's an extruded profile. And as we already learned, we may need to somehow secure this with a metal piece.
Precisely, it will be a metal tube again.
I'm going to add a metal tube here as well. This one.
This is also the easiest to identify PVC windows often.
Now, in case water gets in here, we drain here. So we somehow drill a hole here and then add a cover.
That's exactly also how they do it in wood. And the aluminium is the same. They have also a channel in which they run condensation or drops of water from the rain out in a secured way.
This is the metal cladding
Window
window
PVC.
PVC.
Perfect. It's a nice overview.
So we have the plastic window, we have the PVC, we have the
Wooden one.
wooden one, geometry same, and then we have the metal cladding aluminium in it. And that's the general overview, which then has different materials for the windows.
Perfect.
To be continued. Done. That's it for the day.